Hey, I don't know, Kimish, do you want to start it off and then pass it off as necessary?
Yeah. Uh, just to extra high level context, that for right now we're building the quantization workflow. AOT means a quantization workflow that works on top of export. So this will work for both executor work stream when we do capture the graph and also dynamic export, whatever the export API is. Uh, uh, for quantization, it relates to both post training quantization and quantization aware training as well. So it is we won't be having like won't be having two different entry points and APIs for training of quantization aware training versus PTQ. So you want a single one, which is basically the works on top of export a graph with the code data and ops, and that will be the starting point. Uh, so for that to work for quantization training, we have to make sure that the export graph is actually trainable um, 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 in QAT workflow. And and when you say training, then it has to all the other aspects for training come into picture, like DDP, FSDP, and all of that. So the export plus QAT has to be also compositional, composable with these components. So that's a higher level background for this, and I think Andrew can add more on top of it.
Yeah, I think there's a question first.
Yes, Vaz.
Does this mean you need FSDP traceable first, or what? Like, what's the plan there?
Uh, Say that again. I didn't follow.
Do you need to be able to trace FSDP whole graph first for that to work?
I have no idea. So I don't know the details on those parts at all. But what I understand is like whatever we get from the QAT is something that we wanted to. That must be a trainable graph, and that should decompose with other things as well. Otherwise, it breaks. It also might break, uh, like in a lot of customer workflows where they rely on like the distributed training and whatever. So that's all I understand at this
Kimish,
point.
to get a little more clarity on this, let me make a claim, which is that when you are doing your whole graph quantization changes, I assume that you don't expect to see distributed collectives in those graphs. Is that true?
I would guess so. Although I think if Jerry's here or Andrew can say that, but I think you would. I would guess you got right.
Okay, Vaz, does that partially answer your question?
Um, Kind of, I guess. I think I just need to understand the plan better.
Andrew, do you want to tell us more?
Yeah, let me share my screen. Can you all see my screen? Okay, so
Also, just to say, I think what Andrew might be talking about is more than what I just said, right? I think he's also probably talking about some other challenges. Is that right, Andrew?
yeah, so just on a high level, um, last half we have an end-to-end QAT flow that is working correctly. And then we tested it on a few different models, like in a real training job and both like spot checks as well. But then we realized that there are actually some gaps between making it working perfectly. Uh, so right now it's actually not that robust. And the main reason is a more general problem related to export plus training in general. So one of the problems that we talked about was some ops, for example, dropout, batch norm, and I guess like some auto grad ops. They have different functionality depending on whether this is training mode or eval mode. But then the problem is once you export the graph, you end up getting an A10 subgraph, and then it doesn't toggle between eval and training anymore, even if the user calls that on the model. So one way to address this is uh, something like the following, where we maintain separate train and eval graphs, and then somehow copy over or like sync the buffers between the two graphs. So we end up with something like this. So yeah, so you export them separately, and then you do the quantization specific transformations on them, and then like make sure they're synchronized at some point. So the problem with this is, first of all, the UX is much more complicated than the previous expected UX for QAT. And then this still doesn't allow us to switch back and forth between train and eval, and then have the behavior be correct. So we also discussed some UX improvements to solve these problems. For example, wrapping both of these graphs in a container module that we switch, like we just use the right graph in the right mode, basically. But then we would need some support from, say, the compiler team to support this kind of buffer deduplication between the two graphs. So that's the high level of what we discussed on one way to solve this.
Hi, making bacon.
Yeah, so I was going to ask, so you can also say equivalently that this is not just quantization specific, right? This general, if you wanted to do training on exponential graph, is problem.
Yeah, absolutely. This is not specific to quantization. So yeah, what do people think about this proposal so far? Like, any initial thoughts?
I'm gonna call on people. Sherlock, y'all have been working the most closely on training export.
Okay. I think there's a way to toggle the dropout. Basically, introduce some kind of state into the dropout or batch norm kind of app, which allows you to toggle between the inference mode and training mode. I think that would be easier than maintaining two sets of the graph.
So so the problem that we're seeing right now is dropout actually expands into this subgraph with a lot of different A10 ops. And then what we do to solve that right now in QAT, for example, is we manually replace this subgraph with this one. Basically, we just turn it into a no-op. But then we do this inside convert, which is specific to quantization. But really, this is a more general issue. So I don't know how.
So this looks like the decomposition from the dropout. Can we disable decomposition for dropout in the export case?
If we want to keep the same graph, we probably need the general principle of saying any operators that have different behaviors between train and eval have to be preserved. They cannot be decomposed, otherwise we cannot toggle.
NYC Dark Ritual.
Yeah, I think batch norm is probably the example that makes this the hardest to do. Because with batch norm, in eval, you don't mutate your buffers, and training you do. And right now we don't have a good way to express an export that some state on the model is maybe or maybe not mutated. So input mutations are this thing that are baked in a bunch of places.
So you won't know how to functionalize it?
We're able to functionalize it, but the way that we functionalize input mutations is that we record a bunch of metadata saying, hey, these buffers or these parameters were mutated as part of collecting the graph. And we sort of specialize on which things are mutated or were not mutated. And so we don't have a way to represent this buffer was maybe or maybe not mutated depending on some dynamic property.
In fact, Brian, if we think about the call-in convention for the training versus eval graphs, they're actually different. The training graph would, produce updated buffers as outputs, but the eval graph, you wouldn't want to actually do that because you know.
Yeah, that's right. Buffers. So we're specializing everywhere on these input mutations.
I have a different, more pointed question at the APS sigmoid folks, which is, I guess one is, when are you guys going to engage with quantization? And 2 is how far along is the training export flow from your perspective? Like, I know you guys are doing a special case system for ads, but like just in general, where is it right now?
Are you asking about the export workflow for getting a training
Export
graph?
workflow for training, yes. Yeah, let's talk about export workflow for training.
The way that we get the training graph is through the AOT export joint graph mode. That will give you the forward and backward graph in the same joint graph, which seems different from what Android have here.
Yeah. I think one problem with that, combining that with our APIs, is that we also do these like quantization specific transformations. Like, and these transformations also need backward graph.
Sorry, just to clarify, do you mean you need to transform prior to having split the graph into the joint?
Yes, exactly.
Okay.
Or can it not be done on the backward graph? Oh, sorry, actually, it cannot be done on the backward graph. Sorry, yeah, that's right. Otherwise, we can't generate the backward graph with the observers.
Yeah. So my understanding of what Sherlock is saying is that by the time you finish exporting, you already have a model with the backward graph.
Yeah, like in your case, the training model here is still the forward-only graph.
Yeah.
But in the with the training mode and with the pre-dispatch.
Mm-hmm.
So I have another question. Well, it's the same question as before, which is, are you guys going to engage with quantization at any point, or is that not really something the modelers are interested in right now?
Not at this point, to my knowledge.
Okay. Okay, some other questions. Another question. Okay, Andrew and Kamish, who are the primary, like, the hero use cases for this quantization flow that you're targeting right now?
Kimish, do you want to take that one?
Yeah, so right now, the only, if we were to switch the existing use cases to new workflow, the ones that I'm personally aware, I think Jerry and Andrew can add more, is there's a occlusion detection model that was doing quantization training. This was on the smart glass use cases, and I think speech folks do that, but their workflow is a bit wonky. So I don't know if that's a good example. So these are the occlusion detection is the one example I can think of. Andrew, Jerry, or maybe Supriya also can add more.
Yeah, we also plan to onboard most of the D2Go models as well. So
yeah, that's
like,
right. So D2Go has like a bunch of models that run on, today they run on edge devices, and we are using either the eager mode quantization flow or the FX-based flow for doing QAT. And if we want them to onboard to the new use case, and we need export, like QAT with export to work.
Okay, so then would it be accurate for me to say that these are primarily oriented at edge deployment use cases?
Yes.
Okay. Let me think. Any other comments from the room? I was going to ask a nasty so go ahead. Yes.
Oh, I was just clarifying. They were previously using post-training quantization, right? Do they have desire to stop using that anytime soon? Is there a problem with it?
I think it's really model dependent. So for some models that are very sensitive to accuracy, they are currently doing quantization aware training. And if they just do post-training quantization, then they may not be able to meet their accuracy goals.
So, is the question about how urgent this is? Is that in relation to that?
Right. Like how urgent are we in a situation to kind of replace them? And for these models that are sensitive to numerics, like which models are these? Which users are these? Are they high priority users?
I think yeah, I can explain a little bit. So those models are pretty high priority models, like the ASR model and occlusion detection. So occlusion detection is targeted at day 60, cutoff is September 1st. And ASR model, they also try to enable the Qualcomm acceleration, but because of the accuracy loss, like Superior mentioned, they have to use the QAT because it's using the dynamic quantization, but the backend does not support that. So QAT is a way to improve the accuracy.
I mean, so it's not, if you're asking if is it blocking, is it really blocking right now? I don't think so, but I don't know if it's like Martin, if you want to add more, but yeah.
Yeah, unless there is another way to do the QAT, then it's not hard blocking.
I mean, they have been doing already, right?
Yeah, maybe they are doing like through the old short-term quantization flow.
Right.
And do these models require distributed training?
No.
ASR maybe.
I doubt, but yeah.
Oh, no, occlusion detection is only single GPU.
I'm sorry, Andrew.
Oh, occlusion detection is only single GPU.
Okay.
So these questions are all around like urgency, right? Like, is there a question on whether we actually whether we need to actually solve this problem or not?
Yeah, so this is the nasty question I was going to ask, which was basically, hey, like, you know, training, the like, our basic stance is you do training in Python with PyTorch 2 eager stack. And, you know, maybe you know, certain cases like Sherlock's like get to do export, but it's you know, like there's a very clear segmentation here where you like if you have to ask, you're not in the set that gets to, you know, do export trading. That being said, Edge is in the set where you have to export because like how else are you going to deploy the models? There's this weird interaction though where like the training is happening on server for a model that you are going to export. You don't need to export the training script per se, but there's also a methodological thing where we have failed to convince quantization to like figure out how to do their stuff in eager mode. So like the only way they know how to do it is graph transforms on the whole graph. So we're sort of having this discussion. But like for like just talking like FSDP, right? Like you don't need FSDP on an exported graph per se, right? It's just that, you know, you were running the quantization flow and that puts you in the exported graph world and you're like, okay, can I then, you know, shove it in FSDP in the end?
So even if we keep the distributed training part outside of it, are we saying that, you know, the training, if you want to train your model so quantization and non-quantization, right? So training on the non-quantization path right now can do eager mode training. Are there any use cases where people would do export and compile to make that faster and whatever? So that's one side. If you take then the quantization into the picture, quantization training, that's when I think the issue on export for training comes into the picture. So if there is a use case where you want to actually do export, compile, and train, then I think there is some overlap in figuring out the problems around quantization that is presented here. If not, then this becomes very specific to edge quantization somewhat.
Vasily?
Oh, hey, I guess I just have two quick comments. So one, to me, maybe the urgency of like QT for Edge, you know, that could be arguable depending on which model. But overall, QT is like definitely a thing a lot of people do, and a lot of Edge models ship to production with QAT, and like they need QAT to ship. Like there's a lot of models where you just don't see like good accuracy numbers without doing QAT, and that can be a difference of like shipping or not. It's like it definitely is like an important long-term use case. And I guess my thought about eager mode quantization.
No, we
Well, I
don't have
guess
to
you-
litigate this. Like basically, like everyone on the like compiler team is like, can you do it in eager mode? And quantization team has been like, no, we can't. And like we've had years of
okay.
this. So
I'll just say we would love to do it in eager mode if there is a good way to do it. We just haven't really seen a good way to do it. But like, so
Martin,
if people have ideas, like please let's like brainstorm and figure it out.
Martin.
Yeah, so it may not be just for quantization, like Kimish mentioned. One use case I can think of, we're not working on it now, but for the long term, we are considering to do some on-device training. And in that case, maybe if we can export and then do the training, would that be like still be a good use case even without quantization?
Yes, you would want to export in that case. I absolutely agree.
Yeah.
And in this case, you also want the joint graph exported.
Yeah.
Greg, was that a satisfying answer for you?
No.
Okay. This is why I asked. I want you to push some more. Please push us some more.
I don't think I understand enough of the technical details to push very much. It just seems a little strange to be like, Sherlock, your use case is grandfathered in or whatever, and like this one isn't. Yeah, I think I was mainly reacting to that, but I don't actually know how to solve the like technical problem.
Okay.
Which one isn't grandfathered in?
Basically, things that are not edge and not like ads are like we're like you don't get to export your thing. Like run regular Python for training.
Oh, that. From my point of view, it just flew kind of under the radar. Never really paid too much attention to it until recently, until this week and last week. Maybe we can spend some time kind of looking at the problem harder to see if there's a solution right now that we know it's a bigger problem for quantization.
Yeah, so Greg, to like address your point, which is why are we really grandfathering things in? Another coherent strategy we could take is to be like, okay, the day has come. We are going to seriously commit to export for training, like in its full generality, solving the various use cases that we know about, and just like it's a generally useful idea, like a thing that people would find useful, which is to be able to export a model that is trainable, and then run it in situations. For me, the biggest problem is that I don't really want to I would greatly prefer if we can keep the model where we inline through everything in our traces, and that implies that I need a separate train model and eval model. Like for me, this keeps a lot of the internal simplicity for PD2, with the constraint that your preparation pass has to agree between the application on the train model and the eval model. Vasily?
Oh, I have a question. So I haven't been following in detail like the expert specifics, but is there like annotations on the lower graph saying, oh, this was a dropout, but now this like set of ops was like originally a dropout? Because if there are, it should be like very doable to just custom handle those like weird ops if we have like really good annotations.
But I can take a stab at this. I mean, this has been also very debated topic. Like, yeah, there is annotations like why modules take information and stuff like that, but whether those are reliable or not has been pretty questionable because these are metadata on the nodes and mutations on the graph can arbitrarily drop. I mean, user defined passes also can change these things, right? Because between export and quantization, these two APIs are separate. So so whether you can confidently rely on that, practically speaking, maybe it's fine, but it can break, and when it breaks, it's not clear, right?
Yes, so sort of like it's only two ops, right? That need this is like dropout and batch norm. So if you can somehow like guarantee that it doesn't break for those two ops.
No, but like as Brian mentioned, like batch norm is just extremely complicated. Like it is essential, and like you basically have to pay all the cost because of the buffer management.
I think also the question here is a bit more broader than just these two ops, right? I guess we're also trying to answer the question if export should support training in general, because today we are dealing with these two ops. Tomorrow there may be some new issue that comes up for some user model trying to do QAT on an exported model, and we may need more support there.
And in general, like the inference model and the training model can be completely different. Like, just think about like Llama, for example, right? Like they have a completely separate training stack that isn't the same. MBK make bacon?
Yeah, I was gonna ask, would it be a non-starter if we said that, there is an API available that takes an export graph, allows some mutation that can then somehow magically reflect on the joint graph?
What's the second part? Somehow, what a joint graph?
So basically, for a trainable model, we have a joint graph, right? And the mutations that are being done here for the QAT are done on a forward graph, and then you obviously want those to be reflected. So if you imagine, in one state, basically before the export, you do your insert your observers wherever you want, and you export and get a joint graph so that forward and backward reflects exactly what you want. In the other case, when you're starting from export, you are muting the forward graph, but now the backward graph is not reflecting those changes, and you want a way to reflect those changes be reflected. So what I was asking was that if that option, whether it's non-starter or not, the option being, we have an API that takes an exported graph, you muted muted a method of it, and you can then have a mutated backward method of the same.
It's certainly different.
You can extract a...
Go ahead, Yunan.
What's certainly different?
I was saying it's different from what we have today. Like this is a separate IR definition, that's before AutoGrad. Like it's possible, but it's a new thing. Yunan?
Yeah, I was going to say we do allow you to get a module out of the exported program again, and from there you could, in theory, run AutoGrad to generate a new backward graph. That should, in theory, satisfy your need after modification.
My point is that this doesn't actually work if you have already applied decompositions past AutoGrad, because your decompositions are not generally differentiable. You've also lost important information about was grad enabled or not for various regions. This is basically the pre-dispatch discussion. Like, can you get out the graph pre-dispatch? Martin?
Yeah, if we do this, like you suggested, we have two graphs. One is for the training and one is for eval. And then we can export the backward forward graph. Would the parameters be shared or they are even separate?
You'd want them to be shared. Absolutely.
Okay, yeah, that would be good. Like it's for edge cases, right? We don't have like two sets of parameters and moving around.
Jerry?
Yeah, so I'm wondering, just for if expert doesn't want to support training natively, if it's possible for condition just to, like, let's say we start with the eval graph and get the eval graph exported, and then generate the QAT graph from the eval graph. Because in the end we want to condition we're training this is the eval graph.
I kind of agree in principle of this path. Like, I think it should be just a single export and then use some graph transformation to convert between batch norm in training version versus batch norm in inference version. Both the batch norm and dropout shouldn't be decomposed. They should be preserved as a single node in the graph so that you can just do a single node replacement between the inference mode and training mode, and it's easy to do so with graph passes.
Yeah.
Vasily?
Sorry, I was just hoping to just ask a stupid question. Sorry if it's too stupid. So, like, I can't claim I fully understand the whole discussion, but I just keep thinking about the original issue for this, and it's like local to two ops. And it just seems so much simpler to solve this like locally for two ops, regardless of whether we need to like solve the global, match like a huge training graph to huge inference graphs. Like, are there any like tools or abstractions in this ecosystem where you can just think about like a very localized subgraph just to simplify like this specific issue? And it's not going to solve like training experts inference thing, but like if there are those tools, I feel like they'll solve this specific issue. I guess I'm just curious if there are any these like tool concepts.
So, I mean, I don't know if it's adding or responding to what you said, Vasily, but I want to say that the exported model that we get here, so ideally we like on a as said, we do exi.capture, and whatever graph we get from that, with whatever capture config by default it uses, we should be able to use the same config rather than having to specify different parameters for the capturing, because then we start diverging. So if what you said composes fine with that, where you don't need to have a specially exported graph or capture the graph with special configs, specific quantization. If you don't do that, I think that's fine. But if we have to do that, where we have to capture graph with special configs because of quantization, then it makes it not exactly composable.
Yanon?
Yeah, I was just going to respond to Jerry's previous comment. Jerry, you started your statement by saying if export doesn't want to support training. I don't think we have formed a decision yet. It was just not quite on the radar before. Based on as kind of history lesson of saying there are years of discussion on how to do quantization on eager, it sounds like it's fairly difficult. If so, then it doesn't sound like we have a choice. We're going to have to support more general training on export path then. So just want to make it clear, it's not decided to not support training.
Yeah, sounds.
I think my line in the sand is someone needs to show me a plausible story for how you're modeling batch norm in this regime. And the question to answer is, like, in this, like, IR that is able to be auto-graded, which by the way is a new IR, we do not have this IR. Is it functional? Do you get to assume that there is no mutation? Like, I need an answer to this question. Otherwise, I don't like you have.
And we didn't catch the last thing that you said. You kind of went quiet there.
Sorry. What I mean is, you have to show me how you're gonna like represent batch norm in this IR that is both eval and trainable, and you have to tell me if this IR is going to allow mutation or not. And the thing that has the most puts us in the best situation ecosystem wise is if the IR is functional, and that the so for ecosystem reasons, I would strongly prefer for the IR to be functional, so that we're not continuously fixing bugs where people forgot that you can mutate stuff from under you, and therefore lots of transformations don't apply. But I don't, like for me, you need to pass this test, which is like, if you have a functional IR that works for eval and train, how are you representing batch norm? Like, if you don't have a plausible answer for this, I don't see how you're going to do this entire strategy. This isn't sufficient. This is just a necessary condition for the whole thing to work.
And when you say you are not sure how you're gonna do this thing, that this refers to quantization-aware training.
Yes. So specifically, I want you to give me a functional IR that represents a model that can be both evaled and trained, and you need to be able to represent batch norm in this IR.
So is the challenge that the buffers of batch norm is like it is mutable in training but not mutable in evaluation?
That's correct.
Okay, that means like the exported program, it will have different number of arguments.
Well, if in the two graph world, yes, you would have a different number of arguments because one would be mutating and the other wouldn't.
But if I'm just talking about the more specific, like let's say in the eval mode, even if the buffers of batch norm are not mutated, are they still can we still put them as part of the argument for forward?
I think you do need the buffers for inference. So they'd be arguments, yes.
I see. So if the forward fixed signature doesn't change, what is the problem?
The outputs. Well, I mean, under standard functionalization rules, the outputs change. When you mutate the input, you get extra outputs for your graph, which say what the mutated values are.
So that's basically state update on batch now. That's what you're referring to, right?
Yeah, the state updates.
Can you return original buffers if they are not mutated? Since I'm not familiar with the rules.
So you could say that this graph always returns the updated state buffers, and it returns the state buffers with no changes when you're running it in eval mode.
Right. Wait, are you saying like this is a assumption like the graph should always, so all the return buffers are mutated?
Well, I mean, they are mutated if you are training and not mutated if you're eval.
Right. Is that okay or?
Well, I mean, then you well, when you get the eval model, you're going to have these extra outputs which aren't doing anything.
Right. Right. Then what is the implication on that?
You have additional cost on copying them over. Another thing is, do we have like stateful inference use cases? Or they need to do mutation anyways?
I mean, yeah, like you can think of like an ASR use cases and stuff. They have like state that is returned, that is again supplied back in the. But I mean that's actually not part of the exported program. It actually is written back to the user itself, right? So from your perspective, it doesn't like API perspective doesn't change. And but returning extra output that is a state which is not mutated in eval seems also okay in the sense that from like as I understand Explorer program today, just the one that you get at PyTorch.export. Anyway, wraps around the call method for that really wraps around the parameters and buffers, right? That it will patch at calling time. So at least on the edge side, those that is accounted for when you actually export the program for inference on the execute runtime. So same can be done in some sense. So I don't know if that in itself is a blocker that extra in outputs are returned.
Mm-hmm.
All right. Well, let's wrap this topic up for now. Thanks everyone for the discussion. I guess there's going to be more discussion to be had here. Okay. What should we pack in the last 10 minutes? Let's briefly talk about PyTorch spec serialization. Maybe I can even do this in 5 minutes. So the backstory here is that as part of a work on export, this is export day, some folks added a string format for serializing PyTorch specs. And the reason they added the string format for serializing PyTorch specs is that when you export models, you actually get not only a regular FX graph, which takes in a bunch of tensors and produces a bunch of tensors, but also a PyTorch spec that says, hey, if you have some like Python like struct that nested these tensors in, like it's a dictionary or a list or a tuple with, tuples inside, here's how to unpack it into the flat representation. And then whatever the outputs are, here's how to repack it into the extended output shape. And so in real world inference use cases, this is useful because, for example, we have models that take in keyed jagged tensor as an input. These are logically consist of 3 tensors that you unpack before you run the model on them. But from the server side, it's useful to think of these as one concept. So basically the question was, should PyTorch be in the business of defining a string format serialization of PyTorch specs? Or, and this is my proposal, should this just be left to whatever the container format is? So for example, if you're exporting to Thrift, then you should just have a bunch of Thrift structs that represent a PyTorch spec, and it's the responsibility of whoever is making a decision about what format to serialize to actually come up with a format. Jiangshu.
Yeah, to me, it really doesn't matter a lot as long as as a user, I can serialize PyTorch into some string and load it back. I do think PyTorch has a very settled way of representing PyTorch spec to me. So if we don't do it in the PyTorch core, user will end up very similar duplicated implementation of the same thing. So to me, it brings more value to make it a part of PyTorch. But it is just my preference. Yeah.
And weird question. To what extent is wrapper supposed to be exactly that?
I don't know what you mean by wrapper. What do you mean by wrapper?
REPR, the Python built-in.
Oh, well, I mean, you need to be able to parse it. And you probably don't want to parse it by evaling it. So you need to write a parser.
But whatever is your format, you need to write a parser anyway.
Yeah, well, so this is why I want to delegate it to Thrift, because if I just say you have to generate a bunch of Thrift structs to represent PyTorch struct, I don't have to write a parser because Thrift does that for me. Whereas what we have today is this kind of janky format that it has tons of problems. Basically you can break it if you put colons in your string keys in the dictionary. And also there's no story about what to do with user extensible data types. It just assumes that every data type you want can be represented in a single character. So you basically get 26 data types and then that's it. So I want this to, if we do this in core, we have to do a better job at it. But I'm not really in the mood for designing a full-throated serialization format when you've already got a perfectly good serialization format for wherever your serialized model is going anyway.
Makes sense.
I mean, we can define a JSON serialization. Angela wrote this up after I was complaining about the existing format, so we can put that in. I just
What if we maintain one? We don't have to create our own serialization format, abandon what we currently have. If we maintain one, at least in the future, if we make an expansion to a PyTorch support, we can kind of update in sync for the serialization formats. In your original proposal, if we ask every user to choose their own serialization format, and there's no way we can force them to update, and there'll be compatibility issues.
But there are compatibility issues anyway. Like if you add a new type, right? Like it's whatever is ingesting your exported model isn't going to know how to deal with that type, and unless you're just round tripping to Python. But if you're round tripping to Python, well, I don't know, use pickle or something. Well, you shouldn't use pickle because pickle's a security vulnerability. But okay, so it seems like the overall tenor is we should do something in core. So I guess are people okay with JSON?
No, so my problem with doing something in core is that like, is the thing in core going to support C++ for custom types?
I mean,
or is it just going to support Python to
requirements
Python?
of the systems that are using this, it needs to support custom types. Like at minimum, it needs to support key jagged tensor.
Okay, so are we going to use thrift? Do we take a dependency on thrift like from PyTorch?
Well, if you do JSON, you just like have a name field, and then like I don't even know. We should probably force fully qualified names so that they can never conflict, and then you just have a torchrec.sparse.jagged.key jagged tensor like name.
So if you do it from JSON, then like when you're loading in C++, you get what exactly do you get?
So like for the ads runtime, they would just know how to deal with key jagged tensors. So they'd match against this specifically, know how to translate it from whatever C++ goodness they were getting it from. And with Python, probably it would be like you have a bunch of handlers registered to the names, and then you dispatch to those from the register PyTree thing, and that would tell you how to deserialize.
Okay, so but the design sounds like there is still a user component where the user needs to figure out what they are doing with the JSON if they are using C++.
Yes, that is correct.
Okay.
This is insurmountable, like because this is an entirely Python concept. There's no automatic translation. Okay, so we'll bang on the JSON thing a little more in the PR, but Angela, looks like we'll do your thing. Okay, we have 2 minutes left. Vasily, 2-minute quick update about FP8.
Sure, that's so much fun. Okay, I think no amount of time. Maybe I'll just share our milestones. Maybe 75% there, and then you guys just ping me with questions because I don't know if there's time to take questions here. So okay, FP8 spawned by PyTorch. The first one is what we're landing to core. We already have the FP8 B types, thanks to great work from Nikita and Intel. And we're figuring out how to add the FP8 scaled mathmal. And note that the signature mathmal is not the same as your P32 P16 mathmal. There's a bunch of weird arguments for scales and Amax values for all of the inputs. So we'll have to figure out the exact details of what is going to be named, and I guess how to put it into core. And in terms of UX, we're starting with a module swap that will probably not be the final thing. It's just for experimentation. This module swap is already there, and it's hooked up to emulated compute. Once you have a mathmal, we're going to hook it up to real compute. And it's pretty straightforward how to match the distributed stuff like FP16 FSDP and your row parallel linear, column parallel linear. It's a lot more unclear on what we're going to do with like distributed in FP8. So we need to figure that out. Hopefully by next week, we'll have a better story. And the performance story is not super clear yet, so meeting later to start figuring that out. But basically, you want to make sure all the FP8 offs are captured by Dynamo, and we need to choose whether we need to like lower to NVIDIA's fuse kernels for FP8 stuff, or if you need to build up our own together with OpenAI and try it in stock. This one is very light on analysis or details, and we need to kind of make it better. So I'll maybe stop here because I'm out of time. If somebody has one question, maybe they have time for one question, or you can just end.
Wait, sure. I didn't catch the entire thing, but I guess one opinion I have about this, and I'm not sure if this was already covered, but I think we should be willing to add like explicit operators for the FP8 support to like match it to the appropriate kernels. I don't think we should rely purely on like pattern matching to go from nn.linear to like the FP8 pattern, the FP8 kernels.
Oh, by the way, sorry, who's speaking?
Horace, yeah.
Oh, okay, thanks, Horace. Okay, let me, I guess, note that down. It's okay.
I don't think there was any plan to do pattern matching ever.
Yeah.
Okay, good.
Sorry, so I guess, so to clarify, the app for adding to core, this is like the FP8 Apple. So we don't need to pattern match this. The pattern matching is basically NVIDIA has a bunch of like fused offs.
Yeah.
And we need to figure out, do we need to call them or do we need to like re-implement them in a better way? So like, I think that's what we're talking about here. It's not talking about an Apple.
Okay.
Yeah. Like, I guess, do you like that story better? Or do you still have concerns?
I think the main kind of question on my end is like what the front end API for this is. I see this discussion of like float 8 linear.
Oh, sure. So float 8 linear is a placeholder, and I think once we get to like hooking up FSDP, it'll probably need to become one sensor subclass. So it'd be like a float 8 weight. So that, I think that's pretty likely to be like the eventual UX.
Makes sense.
All right. Thanks, everyone.